It is considered to be the most exciting planet since the discovery of Neptune. The astronomers believe that these could be up to 10 times bigger than our Earth, but still lighter than the ice giants Neptune and Uranus. Unlike Jupiter or Saturn, these giant gaseous planets, they can be made of gas, rock, or a mixture of both. Welcome to my channel. It is time to explore. What is a super? First of all, it should be noted that super-Earth is a reference only to an exoplanet S-size, larger than Earth and smaller than Neptune, but not necessarily suggesting that they are similar to our home planet. The term was coined in 2005 when a group of astronomers gathered at a meeting of the American Astronomical Society. They were looking for a name for a new class of exoplanets with masses ranging between those of the Earth and Neptune. The true nature of these planets remains shrouded in uncertainty, because we have nothing like them in our own solar system, and yet, they are common among planets found so far in our galaxy. Over the last 3 decades, we have discovered all kinds of strange planets we never knew existed, and that have no analog in our solar system. As of March 2021, NASA's database of exoplanets lists over 4,000 confirmed exoplanets. Among them are many types of strange worlds, such as rogue planets without stars, planets with 2 suns, and planets with atmospheres of hydrogen and helium. There is also an increasing number of discoveries of rocky exoplanets which are bigger than Earth. These giant rocky planets are called super-Earths. Super-Earths can be up to 10 times more massive than Earth. We yet know enough about these planets to tell at what point they might lose a rocky surface. But in the range of 3 to 10 times the mass of Earth, there might be a wide variety of planetary compositions, including water worlds, snowball planets, or planets that, like Neptune, are composed largely of dense gas. Exoplanets at the upper limits of the super-Earth size limit can also be referred to as sub-Neptunes or mini-Neptunes. In 2019, NASA's Transiting Exoplanet Survey satellite test discovered a super-Earth and 2 mini-Neptunes orbiting a faint, cool star, about 73 light-years away in the southern constellation of Pictor. The M-type dwarf star is about 40% smaller than the Sun in both size and mass, and it has a surface temperature about 1/3 cooler than the Sun's. The innermost planet, TOI 270b, is likely a rocky super-Earth, about 25% larger than Earth. It orbits the star every 3.4 days at a distance, about 13 times closer than Mercury orbits the Sun, based on statistical studies of known exoplanets of similar size. The science team estimates TOI 270b has a mass around 1.9 times greater than Earth's. The other 2 planets, TOI 270c and d, are, respectively, 2.4 and 2.1 times larger than Earth and orbit the star every 5.7 and 11.4 days. Although only about half its size, both may be similar to Neptune in our solar system, with compositions dominated by gases rather than rock, and they likely weigh around 7 and 5 times Earth's mass, respectively, making them mini-Neptunes. Super-Earths are hard to define, difficult to detect, and even harder to characterize. However, astronomers are continually refining methods of detection and finding new and better ways to understand the properties of these mysterious bodies. One way that scientists are trying to learn more about super-Earths is through the use of telescopes. By studying the light from stars that are slightly dimmer than our Sun, astronomers can look at planets orbiting those stars. If there are any planets that are roughly the same size as Earth, they will block some of the starlight as they pass in front of their star. This is called a transit. By measuring how much the star's brightness dims during the transit, astronomers can determine the planet's radius. They can also measure the star's wobble caused by the gravitational pull of the planet. From this measurement, they can calculate the planet's mass. Together, these measurements allow scientists to classify an exoplanet based on its size and mass. A super-Earth would be one that is bigger than Earth, but not so big that it would qualify as a Neptune. Another way that scientists are learning about super-Earths is through spectroscopy. This technique involves breaking down starlight that passes through a planet's atmosphere into its various wavelengths to see if certain elements or compounds absorb or emit any particular wavelengths of light. If they do, then we may be able to learn something about the planet's atmosphere and perhaps even its surface. In 2016, observations from NASA's Spitzer Space Telescope led to the first temperature map of a super-Earth. The map reveals extreme temperature swings from one side of the planet to the other, and hints at a reason for this: lava flows. The toasty super-Earth 55 Cancri E is relatively close to Earth at 41 light-years away. It orbits very close to its star, whipping around it every 18 hours. Because of the planet's proximity to the star, it is tidally locked by gravity, just as our moon is to Earth. That means one side of 55 Cancri, referred to as the day side, is always cooking under the intense heat of its star, while the night side remains in the dark and is much cooler. Spitzer stared at the planet with its infrared vision for a total of 80 hours, watching it orbit its star multiple times. These data allowed scientists to map temperature changes across the entire world. Could humans live on a super-Earth? Scientists do not yet know exactly what a super-Earth is, so they cannot say for sure whether or not life could exist on one. However, they have some theories. Some scientists think that super-Earths could have a rocky surface like Earth, while others believe they are more like giant gaseous planets such as Neptune. If a super-Earth did have a solid surface, it could support life as we know it. However, if it were more like Neptune, then it would not be suitable for human habitation. There are some potential benefits to living on a super-Earth. For example, because they are so massive, these planets have strong gravitational pulls. This means that if you were to step foot on a super-Earth, you would feel much heavier than you do on Earth. Additionally, because of their close proximity to their stars, many super-Earths are tidally locked. This means that one side of the planet always faces its star, resulting in extremely hot temperatures on that side. However, the other side of the planet is in perpetual darkness and is extremely cold. So if you were to live on a super-Earth, you would need to make sure you lived on the right side. Finally, because super-Earths are so massive, they likely have a lot of resources that could be harnessed by humans. For example, they may have vast oceans of water or huge deposits of minerals and metals. Is a super-Earth out there? In recent years, scientists have discovered many exoplanets that are similar in size to Earth. However, they have not yet found any planets that are definitively a super-Earth. That being said, there are some candidates, and it is possible that we will find a super-Earth in the not-so-distant future. One of the best places to look for super-Earths is around small stars. Small stars have strong gravitational pulls, and this makes it easier for planets to orbit close to them. The problem with this is that planets that orbit close to small stars often receive intense radiation from their star. Radiation can destroy the atmosphere of a planet and make it inhospitable to life as we know it. Despite this, there are still some promising candidates for super-Earths around small stars. Another place scientists are looking for super-Earths is in systems that have multiple stars. Systems with multiple stars can have a variety of different configurations, and this makes it more likely that there will be planets in the habitable zone of at least one of the stars. However, this is also more difficult for scientists, because they need to take into account the gravitational interactions between all of the stars and planets in the system. Despite the challenges, scientists are hopeful that they will find a super-Earth in the near future. If they do, it could provide valuable insights into the formation of planets and the conditions necessary for life. Thank you for watching.